The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. We'd also like to welcome back Bob Badley, who helped us in a previous episode to get the Amazon Alexa up and running, talking to a microcontroller over a USB cable. But now that we've done that, we should just automate everything in the shop. Take it away, Bob.
That's right. So we're going to use our previous knowledge to interact with more things on our workbench. So we'll use the multimeter and get a reading from it and say it out loud. We'll talk over the network connection to the oscilloscope so that we can change its settings and take screenshots.
Oh, hands-free oscilloscope.
And we will interface with the GPIO on the Raspberry Pi so that we can turn bits on and off.
Okay, so we'll be able to do quite a few things. We could also experiment with some of those pre-configured plug modules that you plug into a power outlet, and Alexa can control those as well. So that could turn on and off the soldering iron, the fume extractor, lights, all sorts of stuff.
We're going to automate your workbench so you don't need to use your hands at all.
That sounds awesome. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Well, the pinball thing was such a rousing success. We're going to move on to some other shop equipment.
Yeah, let's automate our workbench.
Let's do it. Okay, so one of the simpler things would be this Fluke Multimeter.
Yeah, so this thing has the IR port on the top.
Yep.
And when we plug it into the device, it shows up just as a regular serial port. So we can take the same stuff we've already written and basically copy paste that whole concept so that we can read the values that are coming out of our multimeter.
Now this is a little different than what we did with the pinball machine because we're having to send a command to the Fluke saying, give me your data, and then the Fluke sends data back.
Right, so before the pinball machine wasn't sending anything back, we weren't listening for any response. We didn't even care if there was a response. But now we want to listen to what Alexa has to say to us.
Okay, how much more involved is that?
Not very.
But I've tested this before and it sends you a big string of, again, human readable ASCII numbers. Can Alexa convert that into a number or is she going to read it?
So we're going to have to take that long comma-separated string and parse it out and pull out just the things that we care about.
And have her say those things.
And have her say those things. But yeah, she will take the number 4 and say 4.
Right, but we would want her to say like 4.59 volts or 4.59 volts.
Right, so this comma-separated string is really nasty, but it says something like MVDC.
Yeah.
So we know that that's millivolts DC, so we can do some parsing to tell Alexa to say millivolts DC.
How about for starters, let's hook this thing up to your terminal on the Raspberry Pi and see what kind of things we get back from it.
Okay.
And then we'll use that to determine what to do next.
Sure. Okay, so we're just going to see if we can read the value on here onto the Raspberry Pi and
over the serial terminal.
Over the serial and see what that long string of comma-separated values comes up as. So on the screen I've got Minicom open and I'm just going to send the command to read. So this serial is waiting for a command.
Right. There's very few commands that it actually responds to, right?
Yes.
This particular Fluke.
Right. One of them is the QDDA, which is query data or something like that.
Yep.
So I send that, and here's this long string.
Oh, yeah.
And it looks like volts DC, that's
when
correct.
It's set to...
And then a whole bunch of weird stuff. Oh, here's the 0.0007.
That's the real stuff right there, the voltage.
Yeah. So we just have to parse this and send back the parts that we care about over the JsonResponse.
Yeah.
Oh,
try it with a battery.
So 6 volts is what we're looking for.
And we could probably...
There we go, 6.046 volts DC.
Cool. So we'll probably have like 3 digits of precision, you know, like thousands basically.
Sure.
Yeah, I mean, this is probably enough. We don't need any more detail than that.
Right.
Well, it's only a 3-digit scope anyway, so.
So in this case, we are only trying to read the value of the meter, so we don't even care what the intent is. So we'll just call it just because we copy pasted and that was easiest. But really we're just asking the Python script to send a serial signal to the multimeter to request the reading, and then we take the response back and we send it to our Python or PHP script. So the PHP script then takes that response and makes it all nice and pretty and splits it up into the individual comma-separated values. And then we take the data sheet for this multimeter and we can convert it into its actual readings and pull out what the values that we care about are. And so we can look at the mode value and do a switch statement and say if it's VDC, then we'll have Alexa say volts DC or millivolts DC or amps or microamps or whatever. For temperature, we can even look at whether it's Celsius or Fahrenheit and have Alexa say Celsius or Fahrenheit. Then we take the value and we put the value in front of the units.
So we learned something about the Fluke. It has an internal reading, and that's what it sends over the serial port, but it's different from what it actually displays on the screen, specifically if it's in kilo, mega, or basically where the decimal point is.
Yeah, so we had to do some quick conversions in our Python or PHP script to accommodate that.
So it, like for right now, it says 1.22 ohms. So on the serial reading, it would actually say 1.22 ohms. But if we changed it to like 0.9963 mega ohms, internally it's actually
996,100 ohms.
But there's another value that tells you where the decimal point is.
Yeah.
And so you're looking at that and then making a decision of how to have Alexa read it back.
Yes. So before we were just taking the reading and sending it, and now we're looking at this unit multiplier part of the CSV. And if it's 3, then we divide by 1,000. If it's 6, we divide by 1,000,000.
Yep.
And then we also put in a kilo or mega if that's appropriate.
Cool. So it tells us where the decimal place is, and we can use that to infer mega or kilo. So what Alexa says matches what's on the screen.
Right.
Because otherwise she'll say like 9,900,600 ohms.
And now she'll say, Alexa, get reading from meter.
1.00 mega ohms.
Close enough.
Let's go even higher. Alexa, get reading from meter.
3.01 mega ohms.
Nice.
Sweet.
And then let's go into kilos. Alexa, get reading from meter.
Did you want me to find reading for meter?
Alexa, stop.
Alexa, get reading from meter.
2.99 kilo ohms.
I think she likes me more.
Yeah, you know how to type into her heart. This data sheet talks about all the different commands we can send to the oscilloscope. If you take a look here, a lot of it is something like there's AFG and then offset output. See how there's some upper and lowercase letters to it? That indicates you don't actually have to type in the lowercase letters. You're going to type like AFG amp L here. So while Bob's setting it up, we can actually kind of, well, not actually kind of, we can just do it. So let's open up a telnet connection with PuTTY. Hey, look, we're talking to the oscilloscope. It's pretty straightforward. So like this command window here, we're just going to do this, but we're going to have the Python script send it over. Let's just type something in and see what it does. Acquire state. Okay, this must be where all the important stuff comes from. Okay, state equals 1. All right, so let's see if we can change it. Okay, acquire state on. Boom. Okay, and then I can also query it with a question mark just to see what the state is. That's pretty cool.
Okay, so in our code, we've essentially copy-pasted, because I love copy-pasting, the previous examples with multimeter, and now we're using different intents. So rather than just read, we've added, we've got stop, run, save, zoom, pan, scale, single, auto set, and repeat. So for each of those, we're very simply saving the action that was requested, and that's so that we can repeat it if the user asks to repeat.
Yeah, that's a text file we were using earlier for reference.
Right, so it just saves that incoming JSON as a text file.
And then it looks like you are parsing it out so you can send it over to Python.
Right, so we take let's look at an example that takes a slot or a variable. So the zoom, it needs a direction, and so we pull the direction slot and zoom in that direction. So over in the Python, it takes those variables that we requested
Right.
and calls the appropriate command. So for example, the zoom command, which takes one argument, we go up to zoom, and first we need to figure out what the current zoom level is.
From the scope.
From the scope. So we query the scope to figure out what the zoom level is,
Yep.
and then get that data back and turn it into a number.
Yep.
And then if we're zooming in, then we divide that by 2.
And
if we're
send
zooming,
it back to the scope.
Right,
So you want to know where it is so you can figure out where it's going.
right. There's no relative command, there's just an absolute command, so we have to figure out what the absolute number is so that we can make a modification to
The
it.
dials probably seem to be relative to us, but they aren't either, really.
Yeah. So there were a couple of things that were a little trickier. So for example, the save command, that is a mess of jumbled characters, but we eventually figured it out from the manual, and we were able to save a ping image to the thumb drive.
What's string A?
So what I wanted to do was prevent overwriting the same file over and over again.
Okay.
And we have to specify a file name. So it made sense to say screenshot and then timestamp.
All right, so you're getting the time right there.
Yeah.
Well, so when I push save on the unit, it automatically numbers them, but we're not getting the automatic numbering when we use the command?
Yeah, so when you send a command, you have to give it the name of the file.
Oh, okay. So again, that's the difference between what the commands can do and what the controls can do.
Right.
Got it.
And then the other thing that was weird was when we were doing the run command. So we had this strange state where if it was previously in single acquisition and stopped,
Yep.
and then we told it to run, then it would go back into single acquisition.
Right, so we have to change the acquisition stop after type.
Right, so here we're just starting with whether or not the previous state had been doing single acquisition. We're
Right.
just telling it not to do that
So we
anymore.
make sure we're always going into the main run state.
Yeah.
Got
So
it.
this
Which
is,
would cover the event of us coming out of a trigger.
right.
Yep.
So this is concatenating two commands together into one thing which we can push out at once.
Cool. So let me get this straight. We have Alexa's interpreting our voice, then she's sending that to your Apache server, which is running PHP, which is calling Python, which is then going down to the scope, and the scope is interpreting it.
Yes.
Alexa, ask scope to stop.
Stopping scope.
Okay, that one worked. Alexa, ask scope to move left.
Panning left.
Alexa, ask scope to move left.
Panning left.
Alexa, ask scope to move right.
Panning right.
Alexa, ask scope to move right.
Panning right.
Alexa, ask scope to scale 1 up.
Scaling up.
Alexa, ask scope to scale 1 down.
Scaling down.
Alexa, ask scope to single.
Setting trigger.
Alexa, ask scope to run.
Running scope.
Alexa, ask scope to pan left.
Panning left.
Alexa, ask scope to move right.
Panning right.
Alexa, ask scope to auto set.
Auto setting.
Beep. Cool. So how about a skill called GERT?
GERT seems like Alexa will hopefully be able to recognize it.
It's a good solid word, GERT. So we could say, Alexa, ask GERT to set pin 5 on. So we could have on, off, high, low, or we could just make high and low be synonyms to on and off.
Right, they mean the same thing.
Right, so Alexa would take care of that. You wouldn't have to worry about it.
Yeah.
Do you think we need set pin, or are we going to add PWM? Is that possible?
PWM is possible, but hardware pin is not possible on all of the pins.
Right.
But you could do software PWM on some of them.
I think there should be, I might be thinking of the extended GPIO. I know there's at least 2 PWMs on there. But yeah, you're right, it might not be on the normal one. All right, I guess my question is, do you think we need to differentiate set and pin as intent and object?
No, I think if we just did pin as the intent, then...
Ask a GERT to pin 5 to off?
Although if you were to just conversationally say set pin, then it would just ignore the set.
Right. Well, there's no reason, because so in your JSON, you would get, I mean, these would, well, actually, you would always get all 4 of these, and you would just parse it the way you need to. So like, if right now we're just doing pins, like you'll get these, but you don't care, because everything's just GPIO, you're just looking at this and this.
Yeah.
But at least it would make it conversational. All right, well, I'll just set it up like this, and then we can give it a try. Do you want to create a table of the standard GPIO that we have available, where it's like 2 to 20 or something like that on the Pi?
So yeah, we have to figure out which numbering scheme we want, because the Pi has all the weird numbers.
Yep.
But then it's also got weird numbers that are related to the BCM versus the pin.
Yep.
And then neither of those are just 1 through a thing.
Right. Yeah, like 0 and 1 are reserved, and you actually start at 2, and then you go up to around 20 if you're doing the GPIO version.
Yeah. But since we're going with the buffered GERT board, the outputs just end up being 1 through n.
Oh, they do.
So why don't we just do 1 through n?
All right, I'll set this up in Amazon, and then why don't you set up a table in Python, and we can get it connected to, we can't use wiring Pi because that's only for the older Pi, so we need to use like Raspi GPIO.
Yeah, wiring Pi is deprecated, and so now we have to use rpi.gpio.
Okay, cool, let's get it set up.
So we hooked up the GERT board to our Raspberry Pi, and the GERT board is just something we had laying around the office. We could have used like the Pi face or just connected directly to the GPIO of the Pi, but we wanted to use the buffered outputs just to add more protection. So Ben set up a skill that has an intent of set, so he can tell me to set a specific pin to either high or low, or on or off, or 1 or 0. They all mean the same thing. That then gets sent to the PHP script, which then sends it to the Python script, which uses rpi.gpio to send the command to the GERT board. So now I can say something like, Alexa, ask GERT to set pin 1 high.
Setting 1 high.
And there it works. Alexa, ask GERT to set pin 8 high.
Setting 8 high.
Alexa, ask GERT to set pin 1 low.
Setting 1 low.
Alexa, ask GERT to set pin 8 off.
Setting 8 off.
And there we go.
Bob, this is the Workbench of the future.
Yes, we have pimped your Workbench.
Wow, it looks so automated. I feel just like Tony Stark, except for I'm not a billionaire.
Yeah, it looks pretty much the same, but we've automated a lot of it. So there's smart plugs connected to your iron, your lamp, your smoke absorber, and your power supply.
So I could turn them on with my voice.
Yes.
Now, obviously, this has a button right there, but things like the smoke absorber might not be as easy to get at.
Right, the switch is on the very bottom of the thing, which isn't even on the table. So now you can say, Alexa, turn on the smoke sucker.
Okay.
And it turned on.
Sweet. Well, let's turn on some other things. Alexa, turn off the smoke sucker.
Okay.
The thing that's cool about Alexa is she can hear you over fans and machinery. Okay, Alexa, turn on power supply.
Okay.
All right, so there's the power supply, and I have the multimeter hooked up to it, but what if I couldn't read the multimeter? Alexa, ask meter for read.
10.08 volts DC.
Oh, I guess that's what the multimeter is reading.
That is.
Yeah, actually, I was talking to a guy in Portland who is fairly blind, and he said that it's really hard to find meters that blind people can use because they can't read it.
Right.
Let's see how turning on the Atari affects the voltage. I'm not even looking. Alexa, ask meter for reading.
9.95 volts DC.
Oh, that's very interesting. Let's hook up the oscilloscope to one of these pins. I don't know, that's kind of hard to read, isn't it?
Yeah.
Alexa, ask scope to auto set.
Auto setting.
Ta-da! Let's see what we got here.
You're using your hands. You don't have to anymore.
Oh, there's a nice square wave.
Alexa, ask scope to set scale out.
Scaling out.
Alexa, ask scope to scale time in.
Scaling in.
Hey, we should set for a trigger event, don't you think?
Go for it.
Alexa, ask scope to single.
Setting trigger.
Ready for the trigger? Boom, there it is. We got a signal.
It works.
That's pretty cool. I think we should save that. Alexa, ask the scope to take a picture.
Saving screenshot.
Great, we've got it. Alexa, ask scope to resume.
Running scope.
I think it's time to solder some things. Alexa, turn on the iron.
Okay.
Boy, it's kind of dark. Alexa, turn on the lamp.
Okay.
I can see clearly now, the darkness is gone.
Alexa, turn on the smoke sucker too.
Sorry, I didn't find smoke sucker too.
Alexa, turn on the smoke sucker.
Okay.
We don't want to solder with the power running. Alexa, turn off the power supply.
Okay.
Well, that's a lot safer now. Alexa, turn off the workbench.
Okay.
Well, That was a good day's work done via automation.
Hands-free.
Yay! Well, that was really cool, making my workbench a marvel of the 21st century.
It is totally automated now.
That's very cool. I especially like the fact that I could control my oscilloscope with my voice, because there's so many times when both of my hands are occupied, and sometimes I'll actually say, hey Felix, could you come over here and push stop for me?
Yeah, and I've had problems where I've been at my computer, which is not next to my iron, and I don't want to go over there to turn it off or to turn it on to start warming up.
Right.
And so I can just say to Alexa to do it, and she does.
Well, what did you think of this episode? Is there anything else in our shop that you think we should have automated? Let us know on the Element 14 community at element14.com/TBHS. You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time, and thanks for coming on, Bob.
Thank you for having me.
Alexa, turn off the overheads.
The very model of a modern Major General. Alexa, beam me up.
Okay, transporting in 3, 2, 1.
Because if you can turn on an LED, you can control the world. Type into my heart.
I'm James Rice. I'm the Engineering Department Manager at Avid Technologies out of Twinsburg, Ohio. We basically are a design service company that takes concepts into full production using our sister companies throughout Avnet, and really leverage that relationship, identifying smooth paths to realize the product.
Cool, so you're the perfect person to help us analyze our hex game and figure out the best way to make it into a viable product.
Exactly.